Okay, so today we're going to be talking about theoretical probability. So theoretical probability, if you read through your notes, is the probability, it is a probability that the measure of how likely an event is to occur. So it's the set of all possible outcomes. That's called the sample space. So for equally likely outcomes, the theoretical probability of the event, they call it P of E, that's how you read it. It's the ratio of the number of favorable outcomes to the total number of outcomes possible. So we've talked about ratios before, so we're going to see these as fractions. So remember that fractions can be reduced. So if you have something that can be reduced, you need to reduce it. Remember that you can reduce by hitting math, enter on your calculator. So just keep that in mind. So we're going to look at simple events first. So with simple events, it's just the probability of one event happening. So we only have one event at a time. So if you look at number 1, it says a jar contains 32 red marbles and 28 blue marbles. What is the probability that a randomly selected marble is red? So in your fraction, you're going to have a numerator and you're going to have a denominator. The denominator of your fraction is going to be the total number here that we have. So we have to total up how many marbles we have. So if you take 32 plus 28, you're going to have 60 total marbles. Goodness. So you want to see what the probability of selecting a red marble is. So you have 32 red marbles. That's the number that's going to go up top. So this is a fraction that can be reduced. So if we reduce that, this reduces to 8 over 15. And that's it. So if you look at number 2, it says a letter in the word restoration is randomly selected. What is the probability of selecting a vowel? So you got to count up how many total letters you have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 letters total. That goes in the denominator. And then we got to count up how many vowels we have. Remember, A, E, I, O, and U are vowels. So if I count up, I have 1, 2, 3, 4, 5 vowels. Now that doesn't reduce, so that is my answer. Okay, number 3. A day in the month of January is randomly selected. What is the probability of selecting a prime number? So we have to know how many days are in January. The total number of days in January is 31. And then we need to look at prime numbers. So remember that prime numbers are numbers that only have factors of 1 and itself. So you could say 2 is a prime number, 3 is a prime number, 5, 7, and you're going to count up how many numbers there are from 1 to 31. Okay? So if you count all of those prime numbers up, you're going to end up with 11. Okay, so if you think about that, I'm going to write out the prime numbers. You're going to have 2, 3, 5, you're going to have 7, 8's not 1, 9's not 1, 10's not 1, 11, 13, 17, 19, 23, 24, 25, 26, 27, no, not 27, 29. And you also have 31. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, yes. So that doesn't reduce either, that's your fraction. So these are just the numbers that only 1 will go into, 1 in itself. Those are the only factors that'll go into those numbers. Okay, if you look at number 4, 2 dice are rolled. What is the probability that the sum of the 2 dice on the next roll is at least 9? So if you think about that, you have 6 possibilities total on the first dice, you have 6 possibilities total on the second dice. So you got to multiply those possibilities. 6 times 6 is 36 total possibilities. And then the probability that the sum of 2 dice on the next roll is at least 9, they have to at least add up to be 9. So if you think about that, you could think about the face values of the dice. They've got to add up to be 9. So you could have, let's see here, 3 and 6. You could have 4 and 6. You could have 5 and 6. You could have 6 and 6. You could have, let's see here, 4 plus 5. You could have 5 plus 5. You could have 6 plus 5. Okay. You could have 5 plus 6. You could have 6 plus 6. Let's count up how many possibilities we have. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's think about something else. Let's see here. Something we haven't done yet. 3 plus 6, 4 plus 6, 5 plus 6, 6 plus 6, 6. 5 plus 6, 6 plus 6. There's one more. Let me think about it. Should be 10 possibilities. Oh, we already had that one twice, sorry. Okay, you also could have had, let's see here. I'm trying to think of all the other ones. You could reverse it, I believe. You have 5 plus 6 and 6 plus 5. You have 4 plus 5. You could have 5 plus 4. And you have 6 plus 3. There we go. There's all of them. Okay, so you have 10 total possibilities because they could be in reverse order as well. Okay, if you reduce that, that reduces to 5 over 18. Okay. On number 5 it says, what is the probability of drawing a heart or a club from a standard deck of cards? There are 52 cards in a deck. If you think about it, you only have 4 suits. You have hearts, clubs, spades, and diamonds. Hearts and clubs, they make up half of the deck. So there's 26 total hearts and clubs together. So if you reduce that, that's half of the deck. Okay. There are 8 books lettered A through H on the shelf. If Scott randomly chooses 2 books, what's the probability that he chooses books A and B? So we've got a combination here. So if you think about it, down bottom, the total possibilities is going to be the combination of what he could choose. So this is a combination problem. Remember permutation and combination, we talked about that. We've got 8 total possibilities and we're picking 2. So the probability that we choose one of those books, we're only choosing one, is going to go up top. So if you calculate this in your calculator, remember I taught you how to do that last week. If you plug that in, you're going to end up with 1 over 28. Okay, let's talk about the complement of an event. So the complement of an event is the probability of the event not happening. Since the sum of all probabilities in the sample space is 1, you're going to take 1 minus the probability of the event happening to get the probability of the event not happening. So you're still trying to figure out the probability of the event happening, and then you're just going to take 1 minus whatever number you get. So it says the probability that it will snow tomorrow is 7/20. What is the probability that it will not snow? So you're just going to take 1 minus that probability, 7/20. You're going to end up with 13/20, and that's your answer. Can't reduce. Okay, a month of the year is randomly selected. What is the probability of getting a month that does not begin with the letter A? So let's just think of getting a month with the letter A. Let's think about that probability. So you know there's 12 total months in the year. And then think about the months that start with the letter A. You have April and you have August. Those are the only 2 months that start with A. So you only have 2. So to get the probability of that not happening, you're just going to take 1 minus that. So you end up with 10/12, which reduces to 5/6. Okay. Number 9, if the spinner to the left is spun, find the probability that it lands on a number that is not prime. So let's just find out the probability of it being prime. Total numbers we have here is 16. And then let's count up the total number of prime numbers here. So we have 2, we have 3, we have 5, we have 7, we have 11, and we have 13, and that's it. So total numbers that are prime here, let me count those up. We have 1, 2, 3, 4, 5, and we have, 6. Okay, so the possibility of it being prime is 6/16. So the possibility of it not being prime, we have to take 1 minus that. So we end up with 10/16, which reduces, if you reduce that, you end up with 5/8. And that's our answer. Okay, number 10, 2 dice are rolled. What's the probability of not getting doubles? So you've got 36 possibilities if you take 6 times 6. And then you've got doubles as in 1 and 1, 2 and 2, 3 and 3, 4 and 4, 5 and 5, and 6 and 6. So you've got 6 possibilities of rolling doubles. So the possibility of not rolling doubles, you're going to do 1 minus that. That gives you 30/36, which reduces down to 5/6. Okay. Alright, moving on. We're going to look at some compound events now. So we have independent and dependent events when you have compound events. It's the probability of 2 or more simple events happening. So with independent, it says when the outcome of one event does not affect the outcome of the other. So all you do is calculate the probabilities of each event separately and then multiply them together. So you're just going to find the probability of event A happening and multiply it by the probability of event B happening. That's it. With dependent, these get a little bit more tricky. It's when the outcome of one event does affect the outcome of the other. So you have to first calculate the event of probability of event A happening first. But then you've got to multiply it to the probability of B happening after A occurred. Okay. So let's look at independent events first. It says a die is rolled 3 times. What is the probability of getting 1s on each roll? So you know that you've got 6 possibilities total. You only have one on each dice. So the probability of rolling a 1 each time is 1 over 6. And it tells us that we're going to roll it 3 times. So you're going to take that and you're going to multiply it 3 times. So if you do that, you get 1 over 216. Okay, on number 12 it says a coin is tossed, then a day of the week is selected. So you got 2 events happening there. What is the probability of getting tails and then a day starting with the letter T? So let's first just focus on the coin toss. You've got 2 total possibilities, head or tails. And the probability of getting tails, there's only 1. So there's the probability of the first event. So the second event, we're talking about days of the week. There's 7 total days. And then there's 2 days starting with the letter T, Tuesday and Thursday. So there's the probability of the second event. So if I multiply those, I get 2 over 14, which reduces to 1 over 7. So that's my answer. Okay. Now we've got a combination here of, not a combination, but a bag here. A situation. So read through that. It says a bag contains 8 red crayons, 14 purple crayons, 6 yellow crayons, and 4 green crayons. A crayon is selected, replaced, and then another is selected. Find each probability. So let's see here. It says the probability of a purple being drawn and then a yellow on number 13. So we've got to figure out how many total crayons we have here. So let's add those up. 8 plus 14 plus 6 plus 4 is going to be 32. So I know my bottom number is 32. Purple, I have 14. And then yellow, still have 32. Yellow, I have 6. So if I multiply these and reduce, if I need to, I end up with 21 over 256. That's the reduced answer. So on number 14, I've got 32 total. I've got 4 green. I've got 32 total. I've got 8 red. So if I multiply and reduce, I end up with 1 over 32. Remember, you can type that in and put math, enter in your calculator. Okay, on number 15. 32 total. I'm going to pick a purple, and then I'm going to do it again. So same possibility, same probability. If I multiply that, reduce if I need to, I get 49 over 256. Okay, and then same thing on 16. 32 total. I have 6 yellow. Still have 6 yellow. So if I multiply and reduce, I get 9 over 256. Okay, so far we've been looking at independent. Now we're going to look at dependent. So it says, using the same example from above, we're going to assume once a crayon is selected, it is not replaced. So if it's not replaced, it affects the total number of crayons in the bag. So not only is your total number going to decrease, but your number of whatever color crayon is also going to decrease. So you got to keep that in mind for the second possibility. So on number 17, at first there's still 32 crayons in the bag, and there are still 6 yellow crayons. But now we're taking that yellow crayon, we're not replacing it. So now there's only 31 crayons in the bag. And there are 8 red. So we're going to multiply those, reduce, and I get 3 over 62. Okay, on number 18, at first there's 32 crayons in the bag, and there's 14 purple. But now there's only 31 in the bag, and there are 4 green. So if I multiply those, reduce, I get 7 over 124. Okay. Now 19, 2 reds. We start with 32 in the bag, and there's 8 red. But now there's only 31 in the bag, and there's 1 less red as well. There's 7 red now. So if I multiply those, reduce, I get 7 over 124. Same possibility as 18. Okay, same type process on 20. Initially 32 in the bag, there's 4 green, but now there's only 31 in the bag and only 3 green. So if I multiply those, I end up with 3 over 248. Okay, last two. Okay, a card is drawn from a standard deck, not replaced, and another is drawn. What's the probability of choosing a heart and then a spade? So, if you think about it, at first there are 52 cards in a deck. And then we've got to choose a heart first. So if you think about it, total there are 13 types, or 13 of each type of card. 13 hearts, 13 spades, 13 diamonds, 13 clubs. So we've got 13 hearts to choose from, but now there's only 51 cards in the deck, and there's still 13 spades. So if I multiply those, I end up with 13 over 204. Okay, last one. So Jack had 4 Snickers bars and 8 Mars bars. He randomly chooses a piece of candy, ate it, and then chose another. What is the probability that both candy bars were Snickers? So total candy bars, 4 plus 8, we've got 12. Okay, both candy bars were Snickers, so we've got 4 Snickers to choose from at first. But now we ate one, so we only have 11, and we only have 3 Snickers bars left. So if I multiply those, I end up with 1 over 11 once I reduce. Okay, so now you've got a homework in front of you. So I want you to work on that homework until the bell rings. I want you quiet and working. Behave. Use your notes. All right, go ahead and get started. Get busy.